Hello everyone, myself Bindu. I am from Department of Information Technology. My mini project topic is on development of human action recognition model using soft computing techniques. And my team members are K. Amshita Reddy and K. Manasavina, and our mini project guide is Dr. N. Rajshekhar sir. So let us start with the abstract. Human action recognition model has wide range of applications from camera surveillance to human-computer interaction like uses. We have many traditional methods like histogram of gradients, optical flow, dynamic time wrapping, which are spatio-temporal dynamics in the video data, which have specific limitations which were later discussed, and we are introducing our project with the proposed system using I3D convolutional neural network, where I3D stands for inflated three-dimensional convolutional neural networks. So which will solve the limitations that are arised in traditional methods. So we are using the data sets from Kaggle, that is UCF 101 dataset, which will contain the videos of 101 classes, and the labels are taken from another dataset, that is kinetics, which will label the data for the videos that are present in UCF 101. It also has applications in security, healthcare, and human-computer interactions. As discussed previously, the existing systems are histogram of gradient, optical flow-based methods, and dynamic time wrapping. These laid the foundation for spatial and temporal dynamics, but it has few limitations, like these are very much problem dependent and it is very much complex to apply them in real world scenarios, so which will reduce the performance. This we can overcome using our proposed system, which is developed using I3D. So the advantages of the proposed system are enhanced motion detail capture. It reduces the sensitivity to the noise and occlusions arised when video data is predicted. It improves the computational efficiency and improves the accuracy and performance. We developed use case diagram, class diagram, and sequence diagram and activity diagram, which will represent the design of the procedure for the project. Use case diagram contains user and the system model, where user can have access to view the data list. User can observe the predicted outcome, where system can perform fetching the data, pre-processing the data, converting it to the GIF, and predict the action from the video, and it will display it in the form of probabilities. Class diagram, we have 5 classes, namely action prediction class, I3D model class, kinetic dataset class, UCF 101 class, and two-stream inflated three-dimensional convolutional network class, which will have their respective methods to perform. Then sequence diagram shows us how the performance of the model is worked based on in a sequence. Similarly, activity diagram is also shown. So the system architecture in the prediction of human action recognition model contains the data. The data is pre-processed using few techniques. The pre-processed data is later trained. Using the trained model, we use the trained model to predict the action. That is the result. Then our final output looks like this. The action that is being performed is predicted in 5 top actions. The one with the highest probability is the action that is being performed in the video. When we come to the implementation part of the code, initially we import the required libraries or modules for the project, like OS, NumPy, ImageIO, TensorFlow, TensorFlow Hub, TensorFlow Docs. And we have UCF 101 dataset helper functions. Initially we have list of UCF videos. This function will list out the videos that are present in UCF 101 dataset, and it will return the video list whenever this function is called. Then we fetch the video using fetch UCF video function, which will extract one of the video by whenever we give the path of the video and returns the path. Later we have crop center square function, which will extract the part of the video where the action is being performed and removes the excess data or the noise data from the video. Later we load the video and then we convert it into the GIF form, where GIF format is the converting the long video into a short length video where the action is being actually performed. We have next one more data set, that is kinetic 400 labels, where we request the labels using this URL and we print length of the labels that we got on requesting the URL. For example, we have 400 labels in the kinetics 400 labels dataset. Then we will be calling the helper functions to perform the operations on video. Initially we call list UCF videos function, where we list out the UCF videos in different categories and videos. We check the number of videos in number of categories and also print in a format like category, number of videos and details of that category. Then we have a function called fetch UCF video, where we are giving the path of one of the video and storing it in the video path. We will pass this variable to the load video function if we and store it in sample video, and later we store it in sample video 1. The difference between sample video and sample video 1 is sample video contains the entire video, while sample video 1 contains only the actual performed action of the video, which is a short length. Then we print the size of that video. We call GIF function by passing the sample video 1, because that is the short length video which we have pre-processed. Here we are passing baby crawling action that is being converted into GIF here. Then we write predict function, which will predict the actions based on their probabilities. For example, here we have baby crawling. The top 5 actions will be listed out and the action that is being performed in the video will be given highest probability. Basing on the highest probability, we can confirm that the action that is performed in the video is crawling baby. Next, we have also tested with the negative test case, where we have given the non-human action. So this is the video of a earth rotating, which is a non-human action. So we would like to test it. So the prediction function is called and the output that we got is invalid. So we have generated various test cases, including positive test cases and negative test cases. Initially, if we start with positive test cases, that is human actions. Whenever we predict the human actions, it will generate the probabilities of top 5 actions that are related to the given video. So the one with highest probability is the action that is being performed in the video. This is the second test case, which is predicting basketball playing. which is 48.53%. Then under musical instruments, playing guitar is being recorded as highest probability. So that is the action that is being performed in the video. Then crawling baby is the action that is being performed in this video. Skydiving is the action that is performed and it is predicted with 99.38%. Then we have also performed test case generation with negative test cases, that is, which is a non-human action. So if you test it with non-human action, it generates the output as invalid. We have also performed it with noise data, which does not contain any human action, so it will generate the output as invalid. So this is the test cases table for human action recognition model for both positive and negative test cases. So the software requirements which we require for this is the libraries mainly, like TensorFlow Docs, TensorFlow Hub, OpenCV Python image, and the programming language which we have used is Python. The hardware requirements are a processor, memory, and the input devices in order to execute your code. Thank you.